Okay, so finally, the other kind of strange part of L'Hopital's rule is when you have an exponential function. And this, what's going on over here is we're going to get something like 1 to the infinity. And this is always confusing. 1 to the infinity, you never know what it is. If something is a little bit bigger than 1, generally it's going to be a big number. And if something is a little bit less than 1, it's going to be it's going to go to 0. So let's see what's going on here. So I don't know what this is, and it is indeterminate form. So I'm going to let y be equal to 1 plus 1 over x to the x, right? Not knowing what to do with that. But I do know that I need to get that variable out of the exponent. And how we always do that is to take the natural log of both sides. So I'm going to write this as x times the natural log of 1 plus 1 over x. And in fact, it looks like if this is my y value, right, x is still going to infinity. So I'm looking for the limit of this, like what's going on as x approaches infinity? What's going on as x approaches infinity? Well, this is going to become infinity times natural log of 1 is 0, and we know what to do with that. We need to write this as a fraction. So I'm going to take the right-hand side and I'm going to write it as natural log of 1 plus 1 over x over x to the negative 1, which then becomes 0 over 0. So I'm going to use L'Hopital's rule. I'm going to take 1 over 1 plus 1 over x, right? That's what the derivative of natural log. But then I have to use the chain rule. So the derivative of the inside, well, this is the derivative of 1 is 0. The derivative of x to the negative 1 is negative 1x to the negative 2. And in the denominator, I also need to take the derivative negative 1x to the negative 2. Oh, and we're taking here the limit as x approaches infinity, right? We're seeing what's going on, the limit as x approaches infinity. Well, these cancel out. So as x approaches infinity, this is just going to give me 1 over 1, which is just 1. However, on the other side, I have the natural log of y, and I'm interested in what's happening to y. So when I rewrite this, this gives me y is e to the first, and that's my limit. And that's not a surprise, in fact, because that's the definition